Okay, so for my first lesson, we're going to talk about exponential functions. So an exponential function is when the base stays constant and x is the variable. And both numbers or both places cannot be variables. So an example of an exponential function would be 2 to the x power, and within 2 to the x power, it'd be 2 to the first, 2 to the second, 2 to the third, and so on, and the number can be negative. So it could be 2 to the negative first, 2 to the negative second, and 2 to the negative third. But when I say both cannot be variables, that would be when x is to the x power. So when graphing an exponential function, you basically just plug numbers into the exponent. So with 2 to the x, it would be when x is 0, y would be 1. When x is 1, y would be 2, so on and so forth, all the way up to whatever number you decide. The farthest I went was 5, so it would be 2 to the 5th would be 32. And whenever you're adding, you move to the left. So it would be x to the 0 power would now be 2, x to the first would now be 4, because whenever you add it here, it'd be 2 to the 1 plus 1 would be 2, and 2 to the second was 4. 2 to the 3 plus 1 would be 16, because 3 plus 1 is 4, and 2 to the 4th was 16 over here. And whenever you're subtracting, it just goes to the opposite. So whenever you're subtracting, you move to the right. So whenever it's 2 to the 0 minus 1, it'd be 1/2. Whenever it's 2 to the 1 minus 1, that'd be 2 to the 0, and 2 to the 0 over here was 1. So whenever it's 2 to the x, and then outside of the exponent it's minus 3, you can go down 3. So that's just a translation down. So you would do 2 to the first is 2, but then on it'd be down 1 to the negative 1. So whenever you do it, it would be just like you're solving any problem. It's just a translation down. So 2 to the first on a normal graph, it would be y would equal 2. Whenever you're moving down 3, 2 to the first would be 3, and then you move it down 3, so it'd be actually negative 3. So your y would end up being negative 3. So that's just a translation down. Same whenever you're adding, so 2 to the first is 2, but then you would end up moving it up 3. So it'd be 2 plus 3, so then your y would end up being 5. All these are just translations up and down. So if it is 2 to the first, 2 plus 1, you would now be at 3. So then 2 to the first plus 1 would end up equaling 3, so then your y would be 3, so then your point would be on the 3 on the y-axis. And that is all for exponential functions. Those are just like the basic things that go on between graphing and just what an exponential function is. Okay, and for my second topic, I'm going to talk about logarithmic functions. So a basic log form would be y equals log b to the x, b being the base. And then the exponential form would be b to the y power equals x. So just some basic helpful facts to know about logarithmic functions would be if the base and x are the same, it equals 1. So that means in the logarithmic form, if this b right here and that x are both 1, then it equals 1. If they're both 2, it equals 2. If b and x are both 100, it still just equals 1. No matter how big it is, it's just always going to equal 1. And if log b to the first power is whatever it is, that equals 0. So if log 100 and then x is 1, that equals 0. If log 2 and then 1 equals 0. Like, no matter what, if x is 1, it equals 0. So in this one, if log base and then b to the x, that equals whatever x is. And last one, if it's base and then log base x is the exponent, that still just equals whatever x is. So if it's 10 log base 10 to the x, it's whatever x is. So if x is 2 and it's 10 log base 10 to the 10 squared, it's 2. So this just is saying if these two are the same and log is in the exponent and that's base in front of there and these two are the same, it equals whatever x equals. So if x is 10, it equals 10. If x is 50, it equals 50. So next I'm going to talk about converting the forms. So right now, this is in log form. Y is 4, and then obviously log, base here is 2, and then x is 16. So if you're converting it to exponential form, right now base is 2, so it'd be 2, and then y is 4 currently, so it's 2 to the 4th, and that equals 16. So the 16 is now what it equals because x here is x here. 16 is x, so now it equals the x. So base here is the down part of, or is the base of log. So here is log base 2, base moves over and becomes the base of the exponent. And then y becomes the exponent. So 4 became the exponent, hence y, that's base y equals x. Base was 2, y became x became what it equals. So now for log base 3 equals 2, or log base 3x equals 2. So now base gets moved over and it's base y. Base is 3, y is 2, and now that's equal to x. And obviously if we were solving it, 3 squared would equal 9, so x would end up being 9. So in this, x would be 9, but whereas converting forms, we're not actually solving. So now we have log base 32 equals 5. So when we're converting it, the base becomes that base right there, but since we don't have a number, it's just b. 5 becomes the exponent, so that'd be 5, and right now that's equal to 32. And as we remember from the exponential functions, 2 to the 5th would equal 32, therefore the base would end up being 2, but we're not solving. And now, if we're going from exponential function to logarithmic function, remember this becomes the base, 3 is what it's equal to, so it would end up being 3 equals log base 2, and then that 8 is x, and that goes at the end of the log base, so it would end up being 8 would be up over here. Next we got 5 to the 4th equals 625. So base would be 5, that's the b up here. So we would have, and the y is the 4 because y is the exponent in the exponential form. So we got 4 equals log, that's the base of the log, so that'd be 5, and then 625 would be on the outside. Finally, we have this one. So we have it equal to x, 15 base, and then 2 would be y. So on the outside here is y, so that would be 2 equals log, the base would be 15, and x is on the outside of log, and right now it's just equal to x, so it'd be log base 15x equals 2. And that is it. That's all I got for logarithmic functions. These are just the helpful facts. Being able to convert forms is really good because then you can convert from exponential to logarithmic easily and without any trouble.